Hello friends and students. So in this lecture video we shall see the working of a shunt clipper circuit, and here when we talk about shunt clipper circuits we will discuss shunt clipper circuits with bias and without bias. So with and without, and these are important circuits. Now why are clippers used? Now shunt clippers are basically used to remove unwanted waveforms. So basically they actually used to remove any unwanted waveforms, and hence they are actually referred to as limiting circuits. So let's begin with a shunt positive clipper. Now before I proceed, there are a few things which we need to remember. Now if I draw a shunt positive clipper, I have the input voltage which is applied across a resistance R, and then we have connected a diode, and the voltage is measured across the diode here. So the diode is connected and I have the voltage applied, and I am measuring the output voltage across the diode D. Now it is assumed that the diode is ideal, and hence when the diode is forward biased, the forward resistance is 0. And hence, when the diode is forward biased, what happens? Since the resistance is 0, the output voltage is nothing but the voltage across the diode. And what is the voltage? Since R is 0, the voltage across the diode would be 0, and hence the output voltage would be 0. So we got to remember that when the diode is forward biased, so when the diode is forward biased, it behaves like a short circuit. And when it behaves like a short circuit, what is the voltage across the diode? The voltage across the diode is 0. So this is one thing you need to remember. So when we design shunt clipper circuits, whether it is a positive shunt clipper or whether it is a shunt negative clipper with or without bias, we have to use a diode, and these are the things which we need to remember. So when the diode is forward biased, since we assume that it is an ideal diode, so therefore the forward voltage is 0. So since the forward resistance is 0, right? So the forward resistance is 0, and hence since the resistance is 0, the voltage across the diode is 0, because V equals I into R. Since R is 0, then the voltage is also 0. So this is one thing you need to remember. So when the diode is reverse biased, so during the negative half cycle here, the diode will be reverse biased. So when the diode is reverse biased, it behaves like an open circuit. So what is the output voltage? The output voltage is directly equal to the input voltage. So the output voltage is equal to input voltage, and here the voltage across the diode is 0. So that is something which we need to remember. Alright, so now let us begin with a shunt positive clipper. Now what is a shunt positive clipper? I am connecting VI, the input voltage, across R, and I have a diode D connected. So what happens during the positive half cycle? As the name suggests, it is a shunt positive clipper. So therefore the positive half of the input should be clipped off. So this is nothing but a half-wave rectifier circuit. So during the positive half cycle, I have plus minus. So this is the input voltage VI. So therefore during the positive half cycle, what happens? Diode is forward biased. So when the diode is forward biased, as I already mentioned, it behaves like a short circuit. So therefore the voltage across the diode is 0. If the voltage across the diode is 0, what is the output voltage? The output voltage is connected across the diode, and hence the output voltage is also 0. So we find that during the positive half cycle, we find that the output voltage is absolutely 0 here. So that is what we observe. So the output voltage is 0. During the negative half cycle, so I have minus here and plus here, So minus and plus. So we find that this is P and N of diode, isn't it? So therefore the diode is reverse biased. So when the diode is reverse biased, it behaves like an open circuit. So therefore the output follows the input voltage. So we find that the output follows the input voltage, so I get the negative half. So similarly, during the next positive half cycle, I find that the diode is forward biased, so therefore the output voltage is 0. And then during the negative half cycle, I find that the output follows the input. So this is a shunt positive clipper. So now to this shunt positive clipper, I can add a biasing voltage. Now with positive bias and with negative bias, so these are the two variations which we should study. Now with a positive bias, so what happens when I connect a positive bias? So this is a shunt positive clipper with positive bias. So therefore we have a diode and then you have a positive bias, and then the output voltage V0 is connected across the diode D, and let this voltage be plus minus VB. It can be 1 volt or it can be 0.5 volts or 1.5 volts. So let the voltage be plus minus VB. So now how do we analyze the circuit? Now let us assume that the voltage, input voltage is 0. So these are the points where the input voltage is 0. When the input voltage is 0, what happens? I have plus minus VB which is connected. So this is P and this is N. So N is connected to the positive. So when N is connected to the positive, what happens? Diode is reverse bias. So let's assume that this is plus VB. This is the positive voltage which is connected across the diode, that is the positive bias voltage. So when the input voltage is 0, what happens? We find that the diode is reverse bias. So when the diode is reverse bias, what happens? It behaves like an open circuit. So when it behaves like an open circuit, output follows the input voltage. So the output follows the input. Till where does it follow the input? Till the input voltage is less than VB. So therefore let us make a note here. When the input voltage Vi is less than VB, then the output voltage is equal to input voltage. But what happens when the input voltage Vi becomes greater than VB? When it becomes greater than VB, then this PN junction diode is forward biased. So when it is forward biased, it behaves like a short circuit. So therefore I can replace this by a short. And what is the output voltage? The output voltage is not 0 as in the previous case, but is equal to plus minus VB. So therefore the output voltage, so this is the output voltage V0. The output voltage V0 is held constant at VB as long as the input voltage is greater than VB, the bias voltage. So therefore the output voltage is equal to VB. Again, the input voltage falls below VB. When the input voltage falls below VB, what happens? Again, I get this condition. When the input voltage falls below VB, the diode is reverse biased. So there is no connection here. This behaves like an open circuit. So therefore, the output follows the input. So therefore, we get a voltage which follows the input voltage. Till where? Till the input is less than VB. So once the input voltage becomes greater than VB, the output voltage will be equal to VB here, as we have observed. So this is what we get. So this is the output waveform what we get. So therefore, during the positive half cycle, the output is clipped off beyond the positive bias voltage VB, and when the input voltage goes below VB, the output follows the input voltage. So this is how a shunt positive clipper works with positive bias, where the positive voltage is plus minus VB here. Now what happens when I have a negative bias? So let's discuss a shunt positive clipper with negative bias in the next case. So here now I have a shunt positive clipper with negative bias. So let's consider what happens when the input voltage is 0. So here it all just reduces to finding when the diode is forward biased and when the diode is reverse biased. So when the input voltage is 0, this is P and this is N, and this is again negative and this is positive. So negative is connected to N. So when negative is connected to N, what happens? The diode is forward biased. The diode is forward biased. So therefore, when the input voltage is greater than VB, so when the input voltage is greater than VB, whether it is 0 or high, what happens to the diode? Diode is forward biased. So when the diode is forward biased, it behaves like a short circuit. So therefore, the output voltage is tied to minus VB. So therefore, we have the output voltage which is tied to minus VB. So the output voltage will be equal to minus VB till when? Till when the input voltage goes below VB. So when the input voltage goes below VB, what happens? So the input voltage has become more negative. So this is minus and this becomes plus. So therefore, the diode is now reverse biased. So when the diode becomes reverse biased, the diode behaves like an open circuit. So when the diode behaves like an open circuit, the output follows the input. So therefore, I get the voltage here, the output follows the input. And then again, when the input voltage becomes greater than minus VB, I have the output which is tied to minus VB itself. So I get a waveform like this. So this is the waveform what we get. So let me write the expression here. So here, when the input voltage is higher than VB, this is a negative bias voltage. Okay, so VB is negative. So VB is a negative voltage here. So when the input voltage is greater than VB, which is negative, then what happens? The output voltage V0 is equal to minus VB. So this is negative minus plus. When the input voltage is less than VB, which is negative, then the output voltage is equal to the input voltage as we have observed. So we have seen a shunt positive clipper where the positive half is clipped off, or the positive portion of the waveform gets clipped off, and we can vary where the clipping takes place by adding either a positive bias, where the clipping takes place in the positive portion, in the positive half of the waveform, or by adding a negative bias voltage where I can vary the clipping here in the negative half cycle. So now let's discuss a shunt negative clipper where we clip the negative half of the waveform. So a shunt negative clipper is very simple. So without bias, so where I have a diode which is connected, and across the diode D I have the output voltage, right? So this is P and N. So now what happens? This is the input Vi, and then we have the output voltage V0. So during the positive half cycle, I have plus and minus. So plus is connected to N and P is connected to negative. So therefore, during the positive half cycle, so diode D is reverse biased. So when the diode D is reverse biased, what happens? It is open. So therefore, the output V0 follows the input Vi. So therefore, during the positive half cycle, the output follows the input. So I get the output which follows the input. But whereas during the negative half cycle, when I have minus plus here, when this is minus and plus, diode is forward biased. So it behaves like a short circuit. So during the negative half cycle, diode is forward biased. So therefore the output voltage is 0. Because we assume that the diode is ideal, so therefore the output voltage is 0. So the output is 0. So I have the negative half which gets clipped. So this is the output waveform what we observe. So actually shunt clippers are very easy. We just have to identify when the diode is forward biased and when the diode is reverse biased. So now let's consider a negative clipper with positive biasing. So this is the circuit of a shunt negative clipper with positive bias. So the voltage is plus VB there. So now what happens? So let us consider the case where the input voltage is 0. So when the input voltage is 0, what happens to the diode? So this is P and N. So P is connected to positive, and whereas N is definitely connected to negative. So diode is forward biased. So when the diode is forward biased, what happens? It behaves like a short circuit. So output is equal to the voltage VB. Alright. So therefore, when the input voltage is less than VB, right? So when the input voltage is more negative, this is a diode here. So when the input voltage is more and more negative, so this is minus plus. So what happens? Diode is always forward biased. So therefore, when the diode is forward biased, it behaves like a short circuit. So therefore, the output voltage V0 will be equal to VB. So as long as the input voltage is less than VB, what is the output voltage? The output voltage is equal to VB. So therefore, the output voltage is constant here. So here also, as long as the input voltage is less than, if this is VB, right, the output voltage will be held constant at VB. So what happens when the input voltage is greater than VB? When the input voltage is greater than VB, the diode now will be reverse biased. So when the diode is reverse biased, it behaves like an open circuit. So when the diode is reverse biased, when the input voltage is greater than VB, the diode is reverse biased. So when the diode is reverse biased, it behaves like an open circuit. So therefore, the output voltage follows the input voltage. So here, we find that the output voltage will follow the input voltage as long as the input Vi is greater than VB. So therefore, the output voltage V0 will follow the input voltage Vi. So this is how we can analyze a shunt negative clipper with positive bias. So as I said, so the clipping takes place here in the positive half cycle itself, in the upper portion, but what happens? The entire negative half is also clipped off because it is a shunt negative clipper. So now let's talk about a shunt negative clipper with negative bias. So this is a shunt negative clipper with negative bias. So now what happens? Let's assume that the input voltage is 0. So when the input voltage is 0, this is P and N. So what is happening here? So we find that the diode is already reverse biased because P is connected to negative, isn't it? So the diode is already reverse biased. So when Vi is equal to 0, diode is already reverse biased. So therefore, we find that the output follows the input Vi. Now what happens when Vi is greater than VB? It is greater than VB, which is negative. So when Vi is greater than VB, what happens? So this is of course plus minus, so the diode will remain reverse biased because positive is connected to N. So therefore the output will follow the input Vi. So as long as the input voltage is greater than VB, which is negative, the output follows the input. So here I find that the output follows the input till the input voltage Vi is greater than VB, which is negative. But when the input voltage Vi becomes less than the negative voltage VB, then what happens? This is more negative, minus and plus, so therefore the diode will now be forward biased. So when it is forward biased, it behaves like a short circuit. So when it is short circuit, the output voltage will be equal to the negative bias voltage VB. So therefore the output is held constant at minus VB as long as the input voltage is less than VB here. Then again, if the input voltage becomes greater than the negative bias voltage VB, the output follows the input voltage and this continues. So this is how we can analyze shunt clipper circuit. So in this video segment, we have seen the working of a shunt positive clipper, a shunt negative clipper along with positive bias and negative bias. They are actually very simple to analyze. We just have to remember these 2 points. What happens when the diode is forward biased? So when the diode is forward biased, it behaves like a short. If there is no bias, the voltage, the output voltage will be 0. And if there is a bias voltage, the output voltage will be equal to the bias voltage because this is a short here. But when the diode is reverse biased, then what happens? It behaves like an open circuit. So when you have an open circuit, when the diode is reverse biased, the output will follow the input voltage. So these are the two main things you need to remember, and you will be able to analyze any shunt clipper circuit, whether it is positive, negative, or whether you have a positive bias or a negative bias. To view all the other videos in electronics, click on the I icon or go through the playlist electronics, and do not forget to like, share and subscribe and press the bell icon to get notifications of further uploads, and thanks for watching.